on camera. We can't say nasty things on camera.
Gosh, Kramer, let's do it up there. Oh, heck.
Darn.
Dun, dun, dun. My back's hurting right now.
Oh!
Okay. Ready? I'm just a little high wired today.
No.
It's a Friday. Okay. Now, I'm gonna calm myself down. You guys calm yourselves down. Okay? Alright. This chapter is all about
Not math.
energy.
Yay!
Which I have plenty of today, yes.
We're talking about
I
Are we going to talk about kinetic and potential? Yeah, we are.
Woo! Energy. Alright. Who can tell me what energy is?
Dead.
The movement of energy is energy.
Is this the title?
Yep. It's also the title of the chapter is energy. Chapter 6.
Fundamental property of creation.
Yeah, I actually made these PowerPoints. I didn't take them from Bob Jones, so they're actually probably going to be more condensed and less writing. I want to do that. I want to in the future modify all of Bob Jones' junk because they're like, well, they ask questions and they're like, they spend 15 slides to explain one concept. It's just kind of. What'd you say? Oh, Bobby. So, Bobby, yes? Yeah, we'll talk about that.
Oh, we already know that.
Ooh, look at that, all super concise for you.
Yes.
And it's simple, white, bullet points, no flashy colors, no crazy football players running into other football players.
Looking like your hands like this.
Yeah, looking like turkeys. Break it.
It's a piece of paper.
Turkey.
Come on, turkey.
Dirty. Is that what you
It doesn't work. Show me.
Which one?
It just had to pop out.
Kramer.
The science teacher can't figure out the paper that way.
No, I don't want that. I don't want the tail popping out.
This way.
Not that.
This way.
Hey, I gave you credit where credit was due.
Like that.
Yeah.
Mr. Kramer.
Uh-huh.
Can you, because that would make back to the
We have to
way
entertain our science teacher with the paper words.
Kramer,
Can't do it.
Such a child today.
You're in the
I feel like
way.
we're the
Oh! Get out of the way.
Someone knows what energy is.
Guys,
Fix your
will you forgive me?
We're math.
Sure. 70 times
Wait, how do you
7.
say sure?
My dad's like, sure.
Oh.
Sure.
Yeah.
Don't
His
corrupt
body
me.
is stored at some
I
point.
am
We're just letting it all out today.
On,
But you
not
are.
and.
Exactly and.
Definitely not. Automobile, autumn. I can give you every word in the English language
Say
that starts
data. Data, data.
with. Doesn't matter. You can
Say
say
it.
however.
Say it.
Data, data.
Yes, data. Which one is it? Data.
Whatever you
No,
want.
it's data. It's
I say data.
I say information.
Okay.
I think
Ready?
that sugar
Well,
having
yeah.
a meeting is stored in your body.
Yeah.
Graham, you're the one distracted.
Yes? A little bit. Yeah, I'm sorry. Yeah.
So is J's gonna be the variable for me?
Oh, yes. I'm glad you said that.
Let's
Let's add another most common unit. So, we have energy is the name. E is the symbol. And actually, you could have a variety of them. In fact, we're actually going to probably more talk about kinetic energy and potential energy, which will have different symbols. But E is a symbol, and its most common unit is a joule or a J.
It's a scalar.
Yes?
So for potential and kinetic energy,
Okay, E for kinetic, E for potential. We'll get to that when we get to it. We'll actually do equations for both, but that's a little bit away ways from now. Okay, it is scalar. Okay, you should know. I should not have to remind you what scalar
It has
is.
no direction.
No direction, just magnitude. Okay. All right. It says no one knows what energy is. What I mean by that is it's very hard to define. We kind of define it by what it does, not by what it is.
So it's kind of like God.
I mean, I can see your similar. I can see the connection. Sure. Yeah. Sure. Okay. Now let me think here. So let's. Joule is a derived unit. It actually is a Newton times a meter. But, so it's a derived unit of a derived unit.
So
That's gross.
Because a Newton is a derived unit. So technically, a joule is a kilogram times a
meter per second.
meter squared per second squared.
What?
Because Newton has a meter in it times another meter gives you a meter squared. So I'm not sure you'll necessarily need to know that, but I'm just showing you so you get familiar with how units are. I don't expect you to be able to have it all memorized, but as you progress through your high school experience and get challenged more and more, by that time, as you get older, you should be able to know and do some of these things well. Okay? Questions on this slide? Pretty self-explanatory up to this point. All right? So, all right, there's your definition of energy.
Yeah.
Is it a band day or a choir day?
Choir.
It's a freaking choir day. Oh my word.
Hey.
What? Choir day.
Watch your mouth.
Sorry.
F word.
Well, guess that.
What? Stop throwing stuff! Oh! That was not called for. Yeah, you threw it in the trash. Yeah. Just accidentally meant to. Yeah.
Can't accident.
Why not?
Did you mean to do something?
It's just like, I'm just like, oops.
Oh, that
You
hit
did
me.
that on
That hit
purpose.
me.
No, I accidentally
Yeah.
meant
Get
to.
it?
Purposely.
The song.
Yeah.
You definitely purposely.
Purposely meant to, accidentally.
Purposely.
Every time it's at open gym, somebody like did that. You go, oh, the back.
You're still school children.
No, you didn't. We were on the same team, so you know, you did school.
Yeah, did we lose?
No, I did not.
Did you lose after I left?
No, we did a different team.
Yeah, well, let's see. Are you the most valuable player on your team?
How? Come on. Do you like that dime I gave you? Like, come on.
That was one good dime. I set a lot of good screens for you.
You
Just everybody else doesn't see the floor very
did. I
well.
know.
You want to be a good basketball player? Get good at screening.
So you're good.
High schoolers stink at screening.
Mm-hmm.
They're awful at
I
it.
can
What is
scream.
screaming? I just seen ours.
Basketball.
I'm good at screaming.
High schoolers are also awful coming off of screens.
That is true. You just taught me how to do things last night.
I mean, that was part of. I mean, there's a
I
lot
can
that goes into it.
scream.
Yeah, I was trying to give you some
Scream.
pointers.
Yeah, the one where like you come off your shoulder, I was going
Scream. I'm like, I can scream if I want to. I'm pretty good at screaming. My vocals are great.
Okay, everybody got this in so I can talk? I mean, I can kind of talk.
Yes.
Alright, so notice how they define energy. Do they say energy is this? I kind of don't define it by what it is. They kind of define it by what it does. Okay? So what does it do? Work. It does work. And work is not the same in physics as it is in real life. When I say work in real life, what comes to your mind?
Job.
You know, it's some sort of job, some sort of maybe physical labor, right? Hey, but guess what? Like in real life, if I'm pushing on this really hard, am I doing work?
Yeah.
Yes, in physics I'm not.
Dang it, you
And here's and here's what work is in physics. Work is done when an object moves because of a force acting on it. Okay? So what about this wasn't work from a physics standpoint? It wasn't moving. Okay, there's also another situation where if you cause a force that is perpendicular to the motion, that's not work either. That force is not doing work. Because we know that a force causes an acceleration, but there's no way a perpendicular force would cause an object to accelerate. Like if I applied a force upwards and it went that way, the force pushing up didn't move it that way, did it? Some other force had to have, right? Okay? So with this idea of work is different from what we normally would say, kind of like the word normal was last chapter. What was the word normal last chapter? What was that dealing with? Perpendicular to the surface. Doesn't mean usual. It means perpendicular to the surface. Work in real life is usually physical labor, a job, something like that. Okay? In physics, work is a force that causes an object to move in the same direction of that force. Okay, and we'll talk more about the definition of work and the equation for work as we progress. But here's, because energy is the ability to do work, we a lot of times use work and energy interchangeably. Energy creates work, work can be done to get energy. Energy gives you work, work can be done to give you energy. You see how they're like inverses of each other, but really dependent upon each other. Okay, and you'll find later when we talk more about work, I'm just kind of giving you some, a little bit of background here before we get in next week into what work is and a little bit more into work. But they have the same unit. Okay, so work is in joules, energy is in joules, because they're very closely related to each other. Okay, an example of this is there's a pen on the floor. I can pick it up, do work to it to give it potential energy so that when I drop it, it falls. Right. And as it's falling, it's doing work. So, what is the ground? Let's progress. There are two forms of energy that you are probably most familiar with, and which we will spend the most time discussing and working on. You are probably fairly familiar with these two forms. Yeah? Potential and kinetic? Can anybody define them before I define them?
Potential energy is like a ball sitting at the top of the mountain, not moving.
Okay.
But it has potential.
Sure. Did you know you can have potential energy even though you're moving?
Yeah.
Okay. I just want to make sure. So what potential energy is the energy stored up either based on your position or condition, because you can have potential energy stored up in the bonds of a chemical. Does that make sense? All right, and then you can perform a chemical reaction and that energy gets transferred to some other form. So it has the potential to give energy or convert energy to another form. Okay, kinetic energy is moving energy. So if you're not moving, for example, that's sitting there, does that have kinetic energy? No, but it actually does have potential energy. Okay, and we'll talk about more about them when we specifically focus on each form individually. I'm just giving you kind of the big picture here. All right, pretty concise right there. Potential energy, kinetic energy. You know, how many slides would Bob Jones probably have?
37.
Yeah, probably. They would have had a slide that said, what is potential energy? And they would have had a slide that said, potential energy is and another slide that said, and here's another way to think about potential energy. And here's a third way to think about potential energy.
Who's Bob Jones?
The maker of your book. Good old Bobby.
Okay.
Can I ask you a second?
Yeah, like Aristotle.
Yes.
What did you say? Did you say Mr. Kramer?
No, I did not. I was just reiterating what Ethan said earlier.
What did I say?
She said at least Aristotle had a hairline.
Oh!
Kramer, it's okay.
Honey, that was me.
I love you, buddy.
That's okay. That's okay. I understand.
Be proud of that.
You know what? You know what, Sid? Fix your face.
Okay.
Be proud of what you got up there.
I'm proud. I'm proud. I'm just making it easier for God to count the hairs on my head. Because He knows them all, right, guys? Amen. It's not really hard for
Hey,
Him, so.
got you a wife.
Got me a
They're all
wife.
haters.
No, my charming personality and
No.
stunning good
I think
looks.
it was your hair. I think it was the. I think it was the neck beard.
Yep.
We have the potential to laugh, but we're not.
Yeah, if you're laughing, it would be kinetic laughter. Yep.
Just for the next.
Yeah, just like Drew Gooden.
Then you can be
No, that is so nasty.
Hey,
Run
you
it down
don't
to
need
the
their
chops
approval.
and into a neck beard.
Oh yeah, dude.
No,
We do that?
Nope.
You wanna know what you can use it with mullets?
Mullets.
Oh, please grow a mullet.
Don't you
Potential
dare.
to grow a mullet.
You can't grow.
There's no.
Can you grow your hair past that? Dude.
Did he just ask that question?
Yes.
Oh, Shane asked the question. What question?
He asked if
Nothing.
Trevor could grow his hair past that.
I can grow my facial hair past that.
I'm not talking about facial.
Yes. Have I ever got a haircut?
Yeah.
Okay,
No,
then
not
yes.
asking.
I was talking about like right here.
Oh,
Your receding
kinetic
hair.
energy.
Oh, yeah, no, it's not just gonna magically form. I mean, I can maybe use some Rogaine or something, but I'm not, self-conscious about the way I look.
Don't dope your hair.
Okay. You guys got this so we can talk here? Almost.
Probably what? Probably what?
Don't do that. Say it out loud.
Don't tell me again.
You won't offend me. You won't offend
I
me.
don't want to start it again, but just keep going.
Say it out loud. There's real potential here.
Okay. All right. Bye.
Say it, Carly.
Do it.
Oh, yes. Say it, Carly.
Did you say it while I wasn't listening?
Yes. Yeah, say it again.
You don't tell me. I'm gonna fail you.
Oh, really?
She pretty much just said
Failing
that
yourself.
clearly you don't care about how you look. Because
Because of how I look.
No, the hole in your pants.
Oh! I'm wearing them again, aren't I?
Just keep it. Yeah.
Darn it! Why do you guys gotta pull this out? Look like a dad for a bit
Throw away and
here.
get new ones.
I don't think
At one point,
Buy you a new pair of pants.
Yes.
I'm just glad
Oh,
all
is that sad? Hey, there's 1 minute left.
This is actually the last slide, so that's why I'm allowing us to be. Let me finish, okay? This is important now. I want to explain the slide. You should have all have written it in by now. These aren't the only types of energy, but they are the main 2 types of energy that we will talk about. Potential energy is the energy of position or condition, and we'll talk more. Don't put anything away. Just let me explain, and you can put it away. Okay. We'll talk more about why position is important. It has to do with gravity. Okay? And then why condition is important. It has to do with bonds, bond energy. Okay? We'll get more into it, just at this point, stop putting stuff away. At this point, I just want you to know that potential energy is energy of position or condition. Could be chemical potential energy, that would be more energy of condition. Gravitational potential energy is going to be more the energy of position. Lastly, kinetic energy is just energy in motion. Anything that's moving has kinetic energy. It depends on how big the movement or the matter is and how fast you're going. And we'll see the two equations, not this week obviously, but next week. Question?
Will we have anything in this to do with momentum?
I mean, there'll be concepts that, I mean, we can't just forget it if that's what you're wondering why. Yeah, probably. Alright, you may leave.
I'm sorry.
No, that's fine. It's fine, I know. I realize that if I continue to wear the pants with holes in them, I'm gonna hear it.
Kramer got some really good on it.
Wow.
You throw them away.
You actually did a lot of problems. You did well, we gotta get them both down, right?
I studied too.
Okay, well, like I said, studying, just study doesn't always help you. When you're studying it, are you like, oh yeah, I understand that, I can apply it. And that's like, because if you're just memorizing, my tests aren't memorization tests. Right? The whole first page was like application, where I was like, I gotta know what rotational momentum is, but then I gotta apply it to a situation. That makes sense? Like the whole problem where it was asking which one does not have angular momentum, right? And you had to look through 4 different examples and see which one was rotating and which one wasn't. Which is okay.
Like my little display earlier?
Yeah, I was wondering, I didn't know it was you at first. I just heard someone running and screaming and they were not screaming. Yeah, I was a little shocked when I heard it was you. Someone dared you or what?
You didn't even tell me anything. You were just like,
Well, I thought like you were getting at something like you fell. I was like, oh, okay.
what if you're sitting there for half an hour and you're not doing anything, you come out and run with us?
Oh,
You know?
Sapper,
We're
you're
closing
right.
anyway.
You're right.
I'm missing one more review worksheet. You know if you have it?
Yeah, it's coming back there. It's not done though.
I know, can we work on it?
Yep.
Yeah, why don't you go grab that? So, I'm just missing 2 assignments from last chapter, that one worksheet, and then what I'm writing down here. And normally, it is technically after the test, normally I would give students 0s on those. That's my policy, I'm gonna give you some grace. Okay, but I want you to do them now, okay? How much of that worksheet do you have? None of it done? Okay. Why don't you work on that? If you come across any problems, just ask me. Come out. Okay? Do you know what equations those are?